hour, and then we'll probably wait another minute or so and then get going. But I appreciate you all customers and partners for joining us today for our session. Jason and Chandra, I'm seeing the attendee count grow. So let's give it, let's say another 35 seconds then. What do you think? Should we kick it off?
Sure.
Great.
Sounds good to me.
Awesome. And welcome customers and partners. Get settled. Hopefully you have a nice coffee or water in hand so we can enjoy today's session and you learn a ton. And welcome to our Hadoop Modernization, Escape from the Batch Error and Unlock AI-Ready Insights. So we'll get started in just a moment or so and looking forward to a great time. Chandra, because you are our fantastic partner joining this session, why don't you give us the green light to get going when you think we're ready to kick off?
Sure, I think we can get started.
Sounds good. All right, well, it's official. Welcome everyone to today's session on Hadoop modernization. So it's really focusing on how organizations can escape the batch error and unlock AI-ready insights with Acceldata and VAST. So a little housekeeping agenda items. So for today's session, we are going to hopefully have you guys learn a lot about this important topic. I'm going to set the stage a little bit, talk about a better way with Chandra, talk about the architecture to make this AI-ready dream come true. Then we're going to talk about perform management. So we'll talk about those facets, some reasons why our joint solution is pretty fantastic, go through a few case studies, then kind of talk about how to get started. So I'm Christina Nebel. I work at VAST with our strategic alliances. So partners, if this is interesting to you, please reach out to me because this is a really important topic. And Jason, can you introduce yourself quickly?
Sure, Jason. I'm our technical director around analytics use cases and AI use cases here at VAST.
Awesome. And Chandra?
Hey everyone, this is Chandrakant Sharma. I work with Acceldata. I'm the global field CTO and VP of field engineering.
Oh, wonderful. So at this point, we'd like to hear a little bit from the folks on the call. So I'm going to launch a poll. The poll is now officially open. And while we're getting some input, so please feel free to add your questions to the chat box. We are going to leave Q&A to the end, but we want to hear from you, get your feedback. So the poll is launched. Let's see. We're seeing some come in. So it's, are you currently running Cloudera or self-managed Hadoop? We're seeing some come in. Yes, Cloudera. Yes, self-managed. We also are seeing some come in that no, they're not. So maybe they're looking at this as an opportunity. All right, the poll is almost done. I'm going to stop it and share some of the results. All right, stop sharing and back to the Prezzo. So thank you for giving your input. And also at the end, there'll be a survey if you're interested in a one-on-one discussion with us. So back to our slides. So I have a young family, and a lot of times stories resonate. So to kick this off, let's talk a little bit about Hadoop. And once upon a time, in what I like to call the digital zoo, there lived a strong, powerful elephant named Hadoop. He was built for huge, massive loads of data, but not fast, but just steady. And for years, he was the star of the show. But the zoo changed. Zookeepers, aka developers, architects, and data leaders, started asking for more. They needed speed, agility, scalability, and so much more. They kept asking him to do more than what an elephant can do. First, they want him to be like a cheetah, because performance matters, as I hope you guys know. Data today moves in real time, streaming, reacting, learning, but Hadoop was built for batch. So while modern engines sprint ahead, Hadoop lumbers along, and he just can't keep up. Then they wanted him to be a monkey, because operations got complicated. To make Hadoop more, we stacked tools on top. Hive, Pig, Oozie, Spark, you name it. And suddenly, this big steady elephant was trying to juggle like a monkey. But he wasn't nimble, and managing Hadoop turned into a full-blown circus, hard to control and even harder to manage and maintain. Then they wanted him to be like a meerkat mob because they needed to scale. Meerkats work in tight clans, communicating quickly and adapting as their numbers grow. They share duties and watch each other's backs. But Hadoop, scaling means more machines, more complexity, and more headaches. It's clunky, it's slow, and doesn't adapt easily. And then another important facet, the cost. The care and feeding of an elephant is not cheap. And Hadoop needs space, power, and specialists. So keeping him alive means constant tuning, maintenance, and firefighting. So the total cost just keeps growing. And then our friends at Cloudera, the zookeeper who brought a toolbox trying to tame and manage the elephant a little better. They offered management layers, support, and patches. But despite these efforts, the costs continued, and the elephant was still slow, complex, and expensive to maintain. So here we are. Hadoop had its moment. He played a vital role in the early start of big data, but today's world has moved forward. We need systems that are fast like cheetahs, nimble like monkeys, and scalable like meerkat mobs, without the huge costs and bill of feeding a full-grown elephant. So the story's true. An elephant can't be the entire zoo. And it's not something we've just heard from, the zookeepers of the world. And I'm not the only one saying. People have lived through this. The architects, engineers, and data leaders who've spent years trying to make Hadoop work, they're saying it too. And we just selected a few different quotes to show that this is not necessarily just something we're making up. Quotes like, "We spent more money managing infrastructure than delivering insights." The HDFS stream has turned into a legacy burden. So we are hearing this, and that's why today our joint companies want to provide a better solution and a better together story. So before I hand it over to Chandra and Jason to kind of talk through some of the more mechanics on this, I just do want to do one more kind of splash on what we're seeing as some challenges for teams still running on these legacy systems like HDFS. So the first being like slow performance and performance bottlenecks, because Hadoop's batch oriented, as mentioned in the beginning, and at its origins, holding back real-time analytics and limiting speed of a modern data-driven decision-making. So slow performance and overall operational complexity. Managing Hadoop's complex, there's cluster sprawl, constant tuning, and fragile dependencies. It really pulls valuable teams from innovation and business impact to kind of managing this day-to-day thing. Now, the fourth, scalability issues and data silos. Hadoop offers some great things, but it often leads to fragmented systems and data triplication, making it difficult to scale. And that makes it tough as your organizations and things grow. And then the last, as we mentioned, is high TCO and unseen costs. So you may be underestimating the true costs of Hadoop, triple replication, growing hardware footprints, and reliance on specialized expertise. It really inflates the total cost of ownership. So what can organizations do? And I'm going to invite Chandra to share some alternatives that organizations can step into today. So take it away, Chandra.
Sure. Thank you, Christina. So when we talk about existing users of Hadoop, or even if we talk about the growing need of processing data at scale, and viable options or platforms that allow for you to process things at scale, specifically in the era where we are trying to become AI ready, and the expanse of data is kind of self-explanatory everywhere, right? Like we've grown out from gigabytes to terabytes to petabytes, and now hundreds of petabytes, if not more, need to be managed in an ongoing basis. And they are required for everything from training your AI models to interacting with them, to processing with them, to innovating with them. Now, that particular driver has left a few key challenges with the system. Folks who are already on Hadoop today only have limited options as to what they can do with their distribution. So either one, you take your proprietary Hadoop and perform an upgrade of your entire stack, which is painful because you're siloed, you're tied with the versions that you exist on today. You cannot innovate at a very fast pace. So you get pushed into a corner for an upgrade, and then you have to go through an extensive project and a cycle that kind of refactors all of these things. Or two, you break free from proprietary chains, and then you look for either managing your own environment by yourself with the existing licenses that you've got, or create your own distribution, which is not very easy to do. While it does appear that everything is open source, and for most of the components within the ecosystem, you've got source code available, but it's not easy to run it at an enterprise scale and scale things from a production-ready ecosystem perspective. And the final option is migrating to cloud. Now, that option has been out there for quite some time as well, and many users have migrated a number of things to cloud. However, whenever you think of cloud strategy, there are two key things that any user or enterprise needs to consider. One is the part whether they are compliant with the cloud standards for industries which have more PII data and stricter compliance rules. Cloud is ideally not an option because you can't move 100% into a cloud. So there's a limiting factor there. You can move partially, but then you end up managing two states of different countries rather than just one single country, which is extremely complicated. The second option basically, or the second thought there basically, is the part where cost basically comes in. While you are trying to juggle between compliance and what can move, what cannot move, the cost of doing things on cloud is very tricky, right? It's a running meter. The amount of data that you move in there, manage, process, operate on, everything comes with a cost. So what do? I mean, enterprises today cannot just do nothing and exist in status quo. They have to innovate, they have to keep moving forward, and they have to adopt with the incoming AI practices and the innovation that is attached with it. So what is required, right? You need to get rid of your inefficient legacy systems. You need to reduce the risk exposure that these systems present as you're trying to think about refactoring or replatforming or re-innovating how you do data today. You have to avoid missing innovation opportunities, or you lose the race. You kind of put your business in question, and control the cost at the same time, because cost of doing things cannot impact cost of business for you. So ensuring ROI remains in control, if not lesser, is always the key goal for every business leader, or even architects at all points in time. They want to do more, better, faster, but at a reasonable cost. So that becomes another key factor there. So you have to do something. And I think that's where VAST and Acceldata basically present with an option that allows users not just to modernize their data stack from a technology standpoint perspective, but also to re-architect their platform. We have seen in recent times that there are major re-platforming initiatives going all over the place. Enterprises are going through operating system upgrade cycles, refresh of hardwares. A lot of these projects are running simultaneously in IT houses all over the world. And this presents itself as the best opportunity to kind of attach, or even independently remodernize your decade-old data ecosystem without actually much effort. So whenever replatforming comes in, it kind of becomes a huge thought for any data leader as to what it's going to cost me, how much time it's going to take, how many teams I'd have to put into sustenance and maintenance versus innovation. And that is where I think the joint proposition that we have today presents the best opportunity, where users can seamlessly modernize without having to redo a lot of work that has already been put in play. So with that, I'll take a pause and transition to Jason so that we can start to explore how this joint proposition basically works and how it makes it easier for enterprises to quickly switch gears and come onto the fast track.
All right.
Over to you, Jason.
Yeah, right on. We're going to go talk a little bit about what VAST does, and certainly in the context of what Chandra was just talking about. So just a couple things about VAST. VAST started, it's a fairly young company. In 6 or 7 years, we've gone from being a startup to pretty much a household name in data circles. So we're cash flow positive. I'm just going to go down here a couple of business items. We've been cash flow positive for several years, which allows us to invest and reinvest in our technology. So VAST is stressed quality, capability, and our business model has allowed us to do that. We're around 1,000 employees now, not 850. This slide is a little dated, but that's okay. Our slides are always going to be a little dated because the company is growing very fast. Our last valuation in about a little over a year ago was 9.1 billion. The company's been kind of growing end over end since then, so that will be a different number the next time that happens. We do another valuation. it is really all about architecture. So we say powered by days, and I'm going to describe what that is in simple terms here soon. But architecture is really the fundamental of the platform. We have a Gartner peer review insight, Gartner Insights peer score that is perfect. Our customers love us because we're just maniacally focused on them. Nothing makes you a better support company than not having to deal with support. So that gets you stars right there. But our support team is first rate when you get there, and that is reflected in our reviews. We have a presence in the AI space, which is fairly fundamental. CSPs, but more particularly any of the neo clouds that you see out there, the AI neo clouds, they are all platformed on VAST. That is a big chunk of our business, as well as scientific computing. We do a lot of fintech. Anywhere that data is extremely important, there's a lot of it, and it's very valuable. So that's a little bit about VAST from that perspective. Going a little bit more deeper into the capabilities and our whole ethos. Architecture is everything. This is where our successes come from. It doesn't matter what you do. You can't really develop or build your way out of an architecture that's fundamentally flawed. And a number of technologies came out several years ago that VAST took advantage of. It's not magic, but we managed to get in at the right time with the right people, and built around a few new core technologies, specifically RDMA over Ethernet, very low latency networks, SCM, which is a very high endurance, high transaction speed form of flash, along with read intensive media, which is a low endurance form of flash, but it's all flash. Without going into specifics, you stick them in a bucket and you mix them together, and you get a price point on a full flash system that starts to look more like a spinning disk system. And if you can get flash or spinning disk and spend roughly the same amount of money, you're going to go for flash, and you're going to do it because it's more performant, it's more reliable, and you can be a lot more confident in what you're platforming on it. The other thing is scale. So what we are able to do is you put these technologies together and disaggregate entirely, meaning that you can get compute, and you can get depth out of the system completely independently. This is something that has been tried for years, but has always been bottlenecked around older technologies, and VAST has in fact turned it into a reality. You can scale arbitrarily with VAST in any way you want to go. We have systems that have gone from very small to systems that in a single namespace are beyond 300 petabytes that we know of. So that's one thing. So on that architecture, we can build a whole lot of things. So we have high degree of capability. We support a lot of protocols. If you need to save state, we can do it. Be that block, structured data, unstructured data, message buses. All of these things are housed in VAST, and that we can support. Performance is a big part of what we do. So it is flash, and we started in the HPC space. We have systems that read as a matter of course just in production, 10 terabytes a second and beyond. So these are systems that just sit there and do that as a matter of course, not as a matter of stunt benchmarking or anything. Cost, of course, you have to bring the cost down. So that's key. That's what makes this price performance. And the other thing is simplification. The quality of the software is very high. The architecture is excellent. And so we're able to build a very simple, easy to use system that scales out and operates like some of the major big file systems that might traditionally been used 10 years ago, Lustre or GPFS. These things, we can deliver that performance in a very simple system these days. This is what the architecture looks like physically. It is a set of, it's fairly simple. It's a set of stateful just servers, nodes. This is an on-premises design right here. We have cloud offerings as well. We're going to focus on data centers here. We have stateless systems that sit on servers that are containerized, and then we have JBoss flash systems that sit next to it, and this is why you can scale them independently, and they sit on an RDMA fabric. And so it's fairly simple, and simplicity is the genius here. Moving forward, we're going to go back to Chandra here and talk about what Acceldata does.
Sure. Thanks, Jason. So to give a quick intro about what Acceldata is as a company and where we came from. So we were founded back in 2018, headquartered here in Campbell, in the Bay Area, US. We've gone through 3 rounds of funding, have raised more than $100 million in capital. As for our deployments, we are currently deployed on production across telcos, BFSIs, health sciences, most governed and audited and compliant clusters that you can think of, which handle a lot of PII traffic, about 40,000 plus nodes with 250 plus petabytes of data under processing and management and observability. And that number just keeps growing every day as our use cases keep growing every day. Um, the vision of Acceldata is to basically provide an all-in-one enterprise data management platform that takes care of both your processing requirements from a scale perspective, gives you the application tier and the platform that allows you to not just be AI ready, but do AI as well, and including all of your existing data engineering and batch processing related requirements as well, and modernizing them as we move along, and at the same time give you a layer of observability across your compute and data verticals that allow you to understand how data is evolving over time, what things are good, what are not good, pretty much certifying your data that it is trusted, it could be trusted, and it is the right data on which you can make your business decisions. So that is in a nutshell about us. Coming on to our product vertical. So how do we enable this? Within observability and data management, we've got two key verticals. The first one is called as ADOC. It is the pillar or the most key part of Acceldata agentic data management that we currently have. It allows organizations to do data and pipeline observability for their entire data landscape. So think of all of the data sources that you have, whether on-prem or on cloud, whether structured or semi-structured, as far as we can connect to it, including the pipelines that basically process it and the orchestration tools used for doing that, we will be able to observe it dynamically. We'd be able to draw out insights and certify your pipelines as well as the data underneath for use. We'd be able to highlight and identify data problems and pipeline problems ahead of time so that you do not miss your data SLAs or your data products do not suffer or your customers and users are not upset about the quality of insights being delivered through your data products. So that is a very key pillar for us. Second comes the observability part on compute. As all of the things are covered within pipeline and data, allowing you to understand how things are progressing, it is also vital to understand the engines that are processing it. Are they in good shape? For both from a performance perspective as well as from the perspective of their individual health, right? Are they buggy? Are they inconsistent? Are they not reliable? Are they not scalable? And what could be done in order to prevent an outage on them? What is the right way to scale them? And finally comes the Acceldata's open source data platform for enterprises. This is where you get all of your required open source ecosystem components, which are managed and certified by Acceldata for enterprise use. This is that particular application layer that allows you to do all of your data lake related processing and moving away from your legacy pillar of your existing Hadoop ecosystem, which is either old version or siloed or not innovating fast enough for you. So it gives you everything that you have today plus a lot more. So the support for varied components like Trino, Pino, and the evolving use of AI stack components and GPU-based processing ecosystems is all enabled through this particular platform. So in a nutshell, ODP basically is a stack which is under Apache licenses. So there is no vendor lock-in for that. It has ease of deployment since it uses an orchestration layer, which is also open source and has automation utilities that have been built on it over decades. You can automate it using Ansible. You can automate it using blueprints, have reliable support. Acceldata has been known to have 0, 7 kind of situations month over month for customers that we've onboarded over our entire existence. Every customer that we onboard, once the onboarding cycle finishes, they have smooth sailing thereon because of the magic source of observability that we bring in along with the platform that we have. We are able to preempt, predict, and resolve for issues even before they occur. The biggest gain for technical teams is that you've got open source freedom. So you do what you want at the scale what you want, and you're not controlled by the compute that you have or at the scale that you want to run things. And that makes it cost effective as well, because there is pretty much no additional overhead licensing attached to it from a software stack perspective. It also allows you to basically have the flexibility to deploy anywhere. So you're not restricted just to the typical pillars of ecosystems that you've existed in the past with like the legacy Hadoop-based data lake environments. You can pretty much deploy anywhere, whether that be on-prem, on cloud, or a hybrid setup. All architectures are fully supported. So why it becomes the best choice? I think of all the things that we've just listed, it allows you to modernize your ecosystem. It's flexible and scalable. It comes built in with observability that optimizes resources. We've had great success with customers who've modernized using our observability and data platforms, where they've saved 30 to 50% just on their infrastructure costs from the perspective of how they process things, not by buying additional or renewing hardware, same exact hardware, same exact capacity, but the yield is 30 to 50% higher. And that is something that we've observed across all our product customer verticals, going from telco to BFSI to health sciences and all over the place, fintech. Finally, it is a seamless transitions for most user. When you're already in a car and you've had it for a while and you love your car and gets the job done, but doesn't go any fast, it is a difficult transition for most people. However, if the transition is seamless, so instead of a car to an airplane, if the transition is a car to another car which goes like an airplane, it makes it a lot easier. So that's what the seamless transition here represents. You'd have same frameworks of working. You'd have better components, faster, more optimized and certified open source stack components. The transition would be seamless from an engineering perspective. You won't have to rewrite all of your code base, the jobs that basically exist today, and still get to do everything that you do today, but a lot faster, a lot more optimized, and with the ability to make it AI driven. We have baked in ML and AI compatibility tools on our stack that allows users to just harmonize the use of their big data landscape with the AI use cases that they want to adopt and innovate on. So what does the landscape then look like, right? This gives you a brief overview of the various layers that exist in a typical data landscape when it comes to data lake kind of a setup, either on-prem or on cloud. And it also allows you to have a fair picture on what each of these verticals within the landscape basically cover and what technologies basically are supported by ODP and are enabled as well. You can pick and choose one on every vertical, or you could basically have multiples from every vertical as per your utilization, because the stack is completely flexible. So from a storage perspective, which is the essence, the heart of any given data lake environment, it does have legacy backward-looking support with Hadoop HDFS from previous versions. It has modernized HDFS as well to be more compliant and compatible with other storage solutions as well, and storage APIs that are more commonly used in a modern data lake ecosystem. So whether you talk about S3, S3A, ADLS, GCS, we've created a layer that allows you to have HDFS and at the same time have cross-reference and compatibility and clear, transparent communication with the required security protocols across all of these API endpoints and use them seamlessly regardless of where they exist. We also have a storage layer enablement for object storage on-prem, which is at an application layer tiered with Ozone. So regardless of the underlying infrastructure that you have, you could still go ahead and create an object storage module. And then finally, for traditional systems, local file systems and NFS mounts are supported. What we've also done, understanding the utilization that users currently have on their hybrid and between cloud and on-prem ecosystems, the interoperability of components, ecosystems like Databricks and Snowflake, we have brought in the open format support, which enables interoperability for all of your use cases between your on-prem solution and on-cloud solution. So you do not have to replicate data in two different places. You can consume data directly from cloud or on-prem win a compatible format, which is already processed and made ready. So basically, if you have a requirement for running a model somewhere in Databricks, but you have to basically copy the data over and then process it to make it Databricks ready so that then it can be used in the model later on. You don't have to do the prep step anymore on cloud. You can simply do it on-prem. It writes in Delta format. It supports Iceberg format as well. Same things apply to Snowflake. All you do is point it to your on-prem system and run. Similarly, you could also have your on-prem job write to your common storage layer, which is shared between your cloud provider. So that also allows you to basically then have an interoperability between your cloud ecosystem and your on-prem ecosystem, seamless. It does have support for all of the evolving and existing data lake file formats as well, from ORC to Parquet to Avro, you name it. All of them are covered within. The hybrid compute allows you to not just utilize the power of CPU and regular scheduling that Hadoop Yarn basically exposed or enabled users to, it also is Docker and Kubernetes compatible. So you would be able to run the components independently and scale them on these and these frameworks as well. And finally, it does have inbuilt support for Rapids that allows you to switch and utilize dynamically the GPU as well as CPU resources that are available from a compute perspective. From a data store, data processing, and science toolkit, all of the predominant engines which are existing and evolving over a period of time are all available. So this gives you a line of sight from point to point migration when it comes to your existing BI dashboards or data engineering related bad jobs or micro bad jobs that you have to move seamlessly from ecosystem to another ecosystem. And for users who are starting afresh, it allows you to bring in a very strong foundation of these battle tested individual components and then build on top of them. Finally, we've got an orchestration layer dedicated for the environment, which is to orchestrate the clusters, the compute that it needs, the storage that it needs, the services, their configuration, etc. to Ambari, and workflow orchestration through both Oozie and Airflow. Oozie allows backward compatibility of your existing Hadoop-based ecosystems that you have, whereas Airflow allows you to just innovate and get to the most latest orchestration layer. From a security perspective, we've got all industry best standards from NOx to Ranger to Kerberos, LDAP, SSL, all support is enabled. We have built the tool forward looking. So the platform is certified for legacy, existing, and future looking operating system and ecosystem components like Java and Python. Moving along, so how do you get to this? What is supported? How difficult or easy can it be? What are your options? So it basically allows all major ways of adoption for your modernization journey, whether you'd like to do an in-place upgrade so that you don't have to buy additional infrastructure for your compute, or you want to do a sidecar approach where you are going through a hardware refresh and you want to slowly but eventually move your production into a parallelly built production environment. So phase-wise decommission and commission of your compute and platform in job ecosystems is something that is supported as well. And finally, the forklift. If you are going through a re-platform and you want to just be done in a weekend, this is the fastest way to go. You parallelly build an environment, keep it ready, keep it warm, move the data, move the jobs, flip a switch, and you're on. That's the fastest and easiest way to move. So all three migration supported. Now, as we were talking about why VAST and Acceldata are better together, the fundamental solution that basically enables us to be better together is the ability to provide our users with a decoupled architecture, which is performant, cost effective, and prevents wastage. It gives architects and technical users to scale independently while all systems or existing legacy ecosystems basically keep you locked in. So in the previous state, if you look on the left-hand side, the image projects what has been happening for the past few decades within the big data landscape. So every time you had a requirement to grow in terms of you had more data to process or you needed to maintain and manage more data, you had to scale vertically in a sense that you had to bring in more nodes even though you did not have peak compute requirements. And when compute requirements were increased, you ended up buying storage hardware. So first off, the replication factor, which is kind of cornerstone for HDFS in terms of performance because it has 3 copies of everything and it serves queries faster that way. But the cost of just expanding by continuous buying of components 3x than what you actually require, and in some cases you don't even require it, is not a good thing for TCO and ROI. But users were dependent on it because there was no viable performant alternative available till this time, which allowed you to scale independently without being locked in shackles, and still maintain the same or get to better performance than what HDFS had to offer in the past. So that is where the decoupled architecture basically now becomes a reality. It is something that technologies have attempted in the past, but not have been successful, and ended up using their decoupled architecture as archival systems. However, with VAST and the stack that ODP provides, you can now use HDFS to S3A transparent bridge, which is as seamless and as highly performant as your HDFS ecosystem, if not faster. And the biggest bang on the buck is the part that if you have to grow your data, you don't have to buy more compute. And if you have to grow your compute, you don't have to buy more of your storage footprint unless you actually need it. So you're not forced, there's no gun on your head, your hands are no longer tied, and you can just scale the way you need it and the way it is good for your business. So moving on to the joint solution, I'll pass this back to Jason now so that he can walk us through some of the things here.
Yeah, this is sort of we're back to doing sort of a summary here, of what we've already talked about. I mean, the joint solution looks like this. So, Acceldata manages observability, applications, support of those applications, takes that application pool and advances it. It takes your current state and advances it to more modern methods, stacks, and gets you into the realm of dealing with AI. VAST handles anything that's data layer, and so this can mean a lot of things, but it handles state, and so which is one of the most difficult parts of any data environment is dealing with that state. And so when you put these two together, you get something really integrated, really valuable, can propel an environment forward, and deal with the challenges that they have today, and get away from essentially coupled environments that are very hard to manage, very hard to deal with, and get to a decoupled environment and get into an easily manageable state. So you can look at this and see that you can look at it, kind of like this, where you're going from a legacy setup where you have your HDFS environment and all of your applications are very much tied to that HDFS file system going forward. And then you can just lip them and separate them apart here and deal with the elements that VAST deals with on the bottom, and then also have Acceldata manage all the applications above it, as well as the observability. So this is really the better together story is the packaging, the performance, and the vision. We have a single pane of glass. We support your existing stack. VAST has, particularly in the realm of object, S3 optimizations, where we can get in parity and better with local HDFS file systems. We'll talk about that in a moment in the case studies. And it's built for the future, and it's built for RTO. So we'll get to the money slides here in a second and look at the case studies. And we're going to let Chandra handle the first one here.
Sure. So the first one basically talks about a large telco enterprise that exists, a large global telco enterprise. Actually, they're kind of the biggest that exists out there. And what they were struggling with, as you all may have heard or would have background on, telcos have very big footprint when it comes to raw data. EDR, CDR, you name it, right? They've got network ops, they've got biz ops, they have a lot to handle, and a lot of users who generate data in near real time or actually real time, and a lot of it needs to be ingested and maintained and processed and managed. So when we first started looking into the use case here, it had some major challenges. There were 60 plus petabytes with 185 terabytes getting generated on an hourly basis. There was a very high replication footprint, and they had grown their clusters significantly, even though they did not need that much compute. They had approximately 35% of compute wastage, compute just lying around, not being utilized, but they had to grow because they had higher storage requirements. There was inability to interoperate between the modernization vision that this enterprise basically had and to become AI ready. They had to split and replicate their data between cloud and on-prem ecosystems just to make it viable for the multiple use cases that they basically had. So they ended up spending a lot. On the on-prem side of the house, because of the legacy stack that was in place, innovation had basically halted. It was not being utilized while resources were available because of the boundaries around the stack and the application tier that basically existed there. So, solution, moving on to Acceldata, Pulse, and ODP platform, which is first part enables observability, the second part gives you a point-to-point migration of your solution without having to undergo heavy re-engineering or re-platforming exercise. So instant results, in less than 5 days, we were down by 30% on storage footprint and overall TCO by 70% on month one, which is enormous considering the size of the cluster that basically existed. We are talking about 100 plus nodes being free and being utilized for other use cases. They were now able to support their on-cloud use cases with the data that they processed on-prem, which even saved them a lot of money on their cloud footprint as well. So process once, consume as many times as you want. Petabyte scale free-up activities were initiated as our observability solution identified inconsistencies and redundancies within the system, kind of wasted footprint, and a lot of it was freed up instantaneously. Reduction of replication footprint, improvement of ROI, and enablement of their AI ML use cases at a scale that they wanted for the data that was being generated at a very high velocity and volume, just put them in the next level altogether from a data ecosystem perspective. So they now have their data processing and AI workloads pointed to Acceldata ODP, which uses both CPU and GPU resources, consumes compute infrastructure, which is completely hybrid, which runs on-prem on bare metals and VMs and on cloud managed Kubernetes instances, and all being serviced through vast data. A single layer of storage that allows them to simply consume data from one place where it is not replicated, where it's cost efficient, and where it is independently scalable regardless of compute. So decoupled in action. All right. Back to you, Jason, for the next one.
Sure. Let's see. We're going to go over and look at a major bank. This is a global tier 1 bank that had a Cloudera environment that they were quite frankly fed up with. They were dealing with costs, particularly costs increasing year over year, and the complexity and limitations of that particular environment. So they did come to us and put our heads together here and were able to outperform their existing HDFS environment. They were able to reduce the footprint, which is going to be on the next slide, which is just a really great story. They were able to save a whole lot, of course, in power and cooling and infrastructure costs. And along the way, they saw us together and earned a lot of trust. Particularly Acceldata earned a lot of trust, and Vast earned a lot of trust here. We came in, did what we said we were going to do, and now they're in just a much better spot. So, we're going to look at this specifically, what this looks like, and we went from 336 rack units in this particular environment and got it down to 80. They went from a raw capacity of 30 petabytes of space. Now this is an HDFS environment, so it is triplicated, down to 6 petabytes of raw capacity in VAST, which amounts to an available capacity of 10 petabytes, and we got it up to 10.7. And this is going from 9 racks to 2. It's going from limits of 180 gigabytes a second to 360, and the thing costs less by quite a bit. We have 80% less capacity needing, twice the performance out of this particular system. Like 22% of the rack space, is what it needed, and then the licensing costs went down as well to 80% of the previous licensing costs. But keep in mind with that, they also doubled their performance and decreased their floor footprint and power and cooling footprint by 80% on top of that. This is really sort of the story of VAST and Acceldata with respect to really getting these costs down. I'll go ahead and go to this last slide here and let Christina take it.
Yeah, perfect. So, first, thank you all for staying on this, conversation. Hopefully you're able to kind of have some of these pieces and take it away. So, kind of the summary, a much better approach, a more modern data stack with our two organizations, VAST and Acceldata. And, I think from a cost reduction standpoint, we're on the same mission. We see a 50 to 70% cost reduction from the VAST side, and then from the Acceldata side, a similar, over 50% cost. So while the cost kind of can get you in the door, it's all the other stuff we're doing. Once the system is more modernized, you can really take place and work for a true AI readiness for your platform. So really excited about that piece. So, certainly better together, our joint solution can have an organization modernize within, days, if not faster, if not months, if whatever the timeline may be. So in terms of next steps, feel free to contact us, over, email, LinkedIn, you name it. We do have an exit survey if you want to schedule a one-on-one session. And, that will be kind of with the technical folks on our sides. So we really want to have more of an engaging conversation where it's like, what are some of your challenges that you're facing? So, huge thanks to the Acceldata team and all attendees for joining us. We did have some questions come in. Actually, any other piece, Jason or Chandra, that you want to add before we dive into the Q&A?
Not at all.
No, I'm looking forward to Q&A.
Yeah, definitely. And thank you for submitting questions, folks on the call. So first one, I think it can be a joint. So how hard is it to move from, let's say, like HDFS to VAST?
I can take that one. So it's actually not difficult at all. In fact, it is very seamless. From like when you think about it, you have to think in tiers, right? So basically, what formats does HDFS support in terms of file format and storage capacity? All of that is supported on VAST as well. So for an application tier, HDFS protocol, or the protocol that connects to VAST as a physical storage layer, is a transparent bridge for the user, for the application, and the components that run on top of it. For example, something like a Hive or Spark, it is just a seamless pass-through. There is no change required on the code, no repoint or refactoring of code or binaries or libraries or dependencies, none of those. You just run your job as is. And the seamless bridge basically allows you to route what was being routed on HDFS earlier to VAST S3A protocol, and furthermore under that the VAST infrastructure layer, and it's just as fast as HDFS. So no operational complexity, no engineering complexity to do the migration, and full support of whatever exists today.
Great, and we've seen it with some organizations as well. And Jason, anything to add to that, or do you want to I'll give you the next question.
No, let's go to the next question. That was a good answer.
Yeah. All right. What is the trade-off between performance and security at the storage layer? And how do modern systems like VAST balance it? Give that to one, Jason.
Okay, so I'll think of it this way. So VAST has implemented parallel, essentially the capabilities of a very fast parallel file system at the file system layer. And this is also true of S3. It's true of our message bus, the event broker, and it's true of the tabular data that we support. So all these things are very performance oriented, but they are built on top of standard protocols. So for instance, in the NFS space, we support Kerberos. In the S3 space, we do everything with AWS v4 signature systems. These are all over-the-wire security and their authentication mechanisms. On the VAST side, we support all various backends to integrate with IT organizations. Active Directories, of course, being one of them. We support key servers for encryption on the disk. Essentially, VAST has a big public sector footprint, and so we have to implement and abide by all the security controls that exist in the public sector. Since we're not doing anything boutique or fancy at the protocol layer, pointing out to people, we can support whatever you expect to see given those protocols, and we don't really have to sacrifice security there, except for, of course, the obvious, which is fairly minimal overheads of dealing with over-the-wire encryption, for example, taking apart an HTTPS packet when you're doing REST activities. Or if you're Kerberized NFS, decrypting and encrypting, but that's all pretty light. So I wouldn't say there's really much performance change there. I mean, if you want to get really into it, you can start talking about key servers, KMSs, when you're talking about object-by-object encryption and latency there. But generally speaking, there's not a whole lot of trade-off.
Awesome, thank you. And another question, and this is just to give a general sense, and feel free to, Jason or Chandra, how long do we think it would take for a bank and other sectors using legacy systems to adopt a system like more modern system like this? We're not going to hold you to your answer, team, but just in general.
Well, I can take the first stab at it. So it kind of depends on the path that you take to migrate. Now, banks as a whole, they have a different charter compared to telcos. But every cluster is very different. Some are mission critical, some are business critical, some are business supporting. In some cases, you have viability to have additional hardware stood up in parallel to existing frameworks that exist. In some, you do not have as much budget to kind of build a parallel cluster, or you're not going through a refresh. And you won't be going through a refresh in the next year or so. You already have the latest and greatest hardware in compute, and you just want to, use the same compute and the same infrastructure for doing your platform better. So a lot of these things kind of drive that decision. But as we've highlighted, as we went through it, we support all three mediums of adoption. So if you do an in-place upgrade, you can be done with even 1,000 node cluster in about 4 weeks. Very seamless. 1 week for audits and prep, 2 weeks to back up and formalize, and the last week to basically implement and get ready. So a single day implementation, 8-hour window, both sides of testing, and then you're done. So actually the real downtime window is 8 hours or less, but everything that basically walks up to it is also considered as part of the migration path. However, if you're doing something like a parallel build and migrate, that is something that you can do in a week. You have the infrastructure and everything available. You stand up a cluster in parallel. Come maintenance time, all you're doing is flipping a switch. So depending again on the volume of data that would need to be moved from point A to point B, and the size of it and the bandwidth we can get, the activity could be done in a day or half a day also. Once the data replication completes, or population of data completes, it's less than an hour to flip a switch. It's just repointing whatever exists today. Sidecar is actually more time consuming. It needs to be done in phases, so it takes longer. But whatever our users prefer and can accommodate, we are more than happy to work on it. You wanted to add anything, Jason, to that?
Yeah.
Nope.
No, good.
Yeah.
Cool. Another question. Thank you, Chandra. And again, we're hearing like days, hours, not years. So we love those stats. But again, personalized to your system. All right. Can we use HDFS and VAST in parallel, like reading data from HDFS and job output on VAST?
So
Jason,
yeah, I didn't have anything to add to Chandra's example because I saw that question coming up. So
there we go.
So the answer is yes. I mean, so if a lot of the core engines that sit in these environments are going to wind up being things like Spark. Spark can absolutely talk to those two data sources at once. You can even join across those data sources, for instance, if they're talking to HDFS locally, because that's what's there in the environment. And there's a VAST cluster sitting there nearby on the network, they can join the two. And this is also true. This is the saving grace of things like Trino, which is also, in this environment. These are data federation layers that are designed to do exactly that, and cross join between the data sources and produce results. This is generally true around things when you get into applications that might be tied entirely to HDFS. I'm assuming there are some that don't have an S3A component. The answer there would be no, not really, but I don't think there's a whole lot of those around that are in common use. So, Chandra, if you have anything to add to that. So.
No, it is, you can parallelly operate very seamlessly. As we said, we've tackled for it at the application tier level where the platform meets the infrastructure. So for an object to interface or a processing engine to interface with both ends of the sticks is very, very seamless.
Awesome. All right, I'm picking one more, and then we're going to drop because we want to launch an exit poll or exit survey for you guys to answer. So last one. What's the future of data-centric security? Do you see intelligence and policy enforcement moving deeper into the storage layer?
I can take those back on that one. So there are various pillars to security that exist for data at rest and data in motion. And then there is security or governance that is implied on the data based on the use case structure of it, right? Like, for example, when Jason was explaining earlier, right, from a vast storage layer perspective, you've got everything you need from a data at rest security endpoint. And when it comes to data in motion security, VAST supports the framework that are required by applications to have encryption over wire or security over wire. And that's what Acceldata does too. So we've got support for SSL, TLS. We've got support for Knox, which gives you perimeter security of it. And we've got support for RBAC through Ranger and Ranger KMS for encryption key management zones. So I think deeper at a physical level, you can have encrypted disks is the deepest level that you can go to. And at the data level, specifically from an application or platform consumption perspective, all of these tools are available, viable, certified, and tested for users to implement, right? So public sector companies, banking companies have a lot of compliance, and they cannot have anything which is unsecure. So this is not something that is going to exist in the future. It exists today and is ready for use.
Awesome.
I'll add a little bit to this very quickly, and this is something that VAST thinks about a lot. Is data going down into the security going down into the data? And the answer to that is yes, particularly around AI workflows, be they inference, RAG workflows, things like that, where you have these very disparate types of data that are all involved in the same types of queries, for instance, vector search. So VAST is, in its next release, will have a vector database. We will have the ability to have workflows work on data as it comes in, vectorize it, and put it in the vector database. And all of these workflows have to be drawn together to create a security model. And in the context of VAST, that security model is consistent from what the unstructured data is, and as it becomes structured, all sits under the same security model. So if you think about it that way, and if that's what you mean by does security go into the data layer, then yes, it very much does. And this is particularly true of the AI space.
Cool. All right. Well, sincerely appreciate everyone holding on to the end. This was a great session. Thank you, Jason. Thank you, Chandra. And, looking forward to having one-on-one sessions specifically of how you guys can help your organizations modernize modernize, or even if you're a partner and looking to get your making recommendations on a better together solution. So hopefully that's going to be VAST and Acceldata. So thank you all, and hopefully meet you in some engagements together. Take care.
Thank you. Have a good one.